So we're now going to be moving into our electrical architecture panel. I will be your moderator for the session as well as the Q&A portion. So once again, please, you'll see that there is a question and answer portion. We might have time for a few questions at the end of the presentation. And I'll introduce the panelists here in a second. So if you, like I said, if you have any questions, please feel free to post them in the chat. So we're looking at increased complexity of cybersecurity controls due to consolidation of connected modules. Today, I bring you our panelists, Martin Sukup from Erdetto, Stephen McKnight for General Motors, and Eric Evancheck from the NCC Group. So I'll go ahead and introduce it just in order as we see on slides here. So Martin, can you go ahead and give us about a 30-second background of yourself?
Sure, thanks, Joby. So I'm Martin Sukup, VP of R&D at Erdetto's Connected Transport Division. Erdetto, of course, is a cybersecurity vendor trying to help companies, OEMs, tier ones, etc., to increase safety and security as we get more and more connected. I personally have been at the edge of IT-OT convergence and the convergence of rigor and agility for about 25 years in telecoms, chip manufacturing, and similar industries. In cybersecurity and cyber defense for about 17.
Thank you very much. Stephen? We may have some issue here. So we'll go ahead and go to Eric.
Hi, hopefully my audio is working for you there. My name is Eric Evancheck at NCC Group, Technical Director in our transportation team. So my focus has been mostly on security consulting in the last few years. Most of that looking like doing security assessment review on wide variety of stuff, but including automotive ECUs and backends that those systems talk to, diagnostic systems, things like that. And then also some tool development, so tools for automating testing, scanning, and exploitation of some common protocols that we see out there in not only automotive, but also some other pieces of the OT and IT world.
So I think we're having some difficulty from Stephen's side. So I'll go ahead and start moving on with the panel then, and hopefully he was able to resolve those and get online with us. So I guess the question I have to Martin, with this increased complexity and consolidation, how does the value of a cyber attack or compromise change? Or does it change, is I guess the better question.
Yeah, I think that's a great question, Joby. And I think, of course, one cyber attack is not the same as every other cyber attack. So maybe we need to dig into that a little bit. If we look at attacks that might, for instance, ransomware, right, where we're looking to disable some feature of the car, we're looking to get control. If we're looking at botnets, these kind of cases where it doesn't matter so much what we get control of, but the value comes from some kind of disruption or use of a part of the vehicle. In these cases, the value increases significantly because access to one part of the system now gives you much more access, control and restriction of more user features or safety features, as well as more CPU power. Right, if you're trying to exploit for nefarious purposes. Any attack that would be specifically targeting, I don't know, people's radios because we want to broadcast propaganda or something, right? Then the value doesn't change. So I think in most cases, it does have a significant change in the value. And we need to think about that when we're modeling the threats, because really the way we look at attacks needs to change.
So when you talk about modeling attacks, does this change how you incorporate, say, like a Terra into your systems engineering model at all, do you think?
Yeah, so that's a good question. I think if we look at it from an overall systems engineering and security concept kind of point of view, it doesn't really change things. Although we probably need to start looking at these system-wide models earlier in the design process than we used to. Because there was more isolation, the view we had on system threats, I think, typically happen later in the development cycle than it needs to in this kind of more consolidated case. I'd be interested to hear what Eric has to say, given his experience with ECUs, though.
Yeah, I think one of the big differences we'll see there is just the fact that whenever we have these systems that are going to have to get more complex in order to share these resources, you end up in places where there's going to also potentially be more attack surface. And what we've seen a lot historically is that you'll have a chain of vulnerabilities that typically leads to an outcome in a lot of these systems, right? So it's very rarely that there's one item that breaks everything, and it's most often a chain. And this is sort of putting a lot of elements of those chains closer together in some cases, and that's always going to be interesting to us, because you might have an attack that before, well, we compromised some controller, but we couldn't do much with the outcome. Whereas now, if it is possible to access different resources because they've been consolidated, that could turn into a much higher damage potential attack.
Thank you. And then kind of either to Martin or Eric, how do you feel this changes sort of like inter-process communication? I mean, we're talking about these solutions are likely containerized or hypervised or some combination of that, and it probably changes the way that they communicate, since it's no longer over CAN, right? How does it affect the security of those connections between those different sort of address spaces or operational spaces?
I think it's a good question of whether we, how we change that and what we change it to. I think if we don't create enough separation, then we increase the risk. At the same time, you might see by staying in a certain amount of memory space or cache space, we may gain enough performance to be able to spend some more performance on security features, right? And I think this is one of the things that to me is interesting about the consolidated platform is by spending less on network serialization, by spending less on cooperation between units, do we gain, how much performance do we gain that we can then spend to add a higher level of message authentication, to add more filtering and threat detection, right? So I think although it increases the risk, by being on the same unit and potentially increasing the compromise, it also gives us some opportunities perhaps to increase the protections that we put in, right, and gives us higher budget. And I think maybe just one more thing on that before you pass off, Joby, is I also think we talk about the threats and we talk about design. We don't talk a lot about the testing. And I think when you talk about security testing and you talk about covering angles and you talk about what we can do with fuzzing, once you're in a consolidated space, you can actually do more than you used to be able to do when you had to do it across 30 different units.
Great. And I see Stephen is able to join us now. Stephen, do you have any opinion on what Martin just said, or?
I tend to agree with Martin. I really do. I tend to agree with Martin. I think consolidation not only gives, a bigger feature set or one that can be enhanced farther down the road because of the hardware constraints are further removed. Because in the existing ecosystem today, we have capacity issues, whether it be the CPU, whether it be the memory. Having bigger compute and more RAM will bring more features, and some of those features could be specialized security things that we introduce that we necessarily may not have been able to do in the past, whether it be, more in-depth IDS, things like key provisioning and the like. And I agree that as we write requirements and as we implement these, this larger ecosystem on a single box, that our validation will change as well, and we'll have to look at it and have rigor in our validation, much like we do today, except the model is no longer decentralized. It's more in a centralized compute platform. Obviously, there is isolation of the logical form more so than the physical one.
So since you brought it up, does it make sense to fully shift that isolation from physical to logical? Stephen?
I don't think it's possible to completely shift into a full logical suite, simply because kind of the way I imagine this happening, the way it's happened up until now with hypervisors, with microkernels, is we're not doing everything on a single compute platform. We're doing things like infotainment or some of the autonomous type of activities where you're not controlling the entire car in all aspects. You're doing that in a portion. So I think we've got to keep CAN, more isolated and potentially with a second micro than like we have traditionally, and that will continue until CAN kind of gets pushed farther and farther away from this central compute, which CAN is it's used for propulsion mainly. And amongst a variety of other things. So I think we need to kind of keep that in mind and balance it. We may get to full logical isolation, but I think there's always going to be some form of physical, because I think also the central compute will be even potentially not singular, but zoned off, and things like that in the architecture.
So Eric, what's your take on that separation? As somebody who works with these types of modules and does exploration and tries to execute attacks, how does that affect the attacker maybe?
Yeah, so there's a few pieces of that. In terms of the separation and sort of the limitations of what we'll see, as I think Stephen discussed there, it's not just security here, right? Like, if you're trying to do a hard real-time system controlling an engine, maybe that's not the best thing to put on a hypervisor and have a bunch of layers of things in between. That being said, CAN has actually been, people in the security community have complained about CAN for security purposes for a number of good and bad reasons. But one thing that CAN has done is provided a very standardized, straightforward way for different tier suppliers to interface their stuff together. So, if you give someone a DBC file, it's got all the definitions inside of it, and I think probably any tier 1 supplier is going to be able to understand how to deal with those. Hopefully, they probably have code that will generate fairly robust, because they've been used all over the place, implementations to take that data and take it off the CAN bus and turn it into local data. As we move to sort of more complex systems for that, it's going to get a lot muddier, just because it's probably not going to be 8 bytes at a time that are well defined like that. We could probably simulate CAN over these systems, but it tends to be that once you start to give people more tools, they come up with more complex ways to use them, and they might need to. You can't stream video over CAN, for instance, and that's where we often see a lot more challenges come in. Just any time that you're looking at larger, more complex payloads and information sharing between systems that is more complex, there's just more opportunity for bugs to creep in, more challenges for doing things like access controls when they actually exist, and trust is not just implied.
Thank you. So in that vein, Martin, how do you think that the mitigation strategies would need to change in order to protect these modules over their, what we assume is extremely long lifetimes?
Yeah, I think I think this already speaks to connected modules, but the more consolidated they are, the more I think we need to think about the long-term life cycle. I also think when you talk about consolidation and you talk about hypervisors, you probably have even more shared code, shared infrastructure, shared components than we have in today's automobiles. And so, you know, like in the last discussion, kind of, I think as an industry, we have to look at how are we collaborating to mitigate risks that impact us all, right? Not a single vendor or a single OEM. And then, you know, I think kind of what I was alluding to earlier is at the same time, if we're now talking about message protocols that are more complex and more dangerous, but maybe give us some capacity to do interesting things. If we're talking about hypervisors, but more shared operating systems and more shared infrastructure at the physical and logical layer, right? Some of this may be at the physical layer, but you now have the same physical layer maybe being shared by more functions within the automobile. I think it lets us look at how we build mitigations in a kind of more centralized and broad way instead of solving point things. And I think, you know, that takes more investment because, you know, to Eric's point, the solutions may be more complicated because now we've given people tools to break more things. But at the same time, it gives us the power maybe to solve problems across a whole set of modules with a single solution. So I think we're going to see more consolidation and similarity of solutions versus the kind of point solutions delivered in different ways by different vendors all across the industry like we see now.
So I guess a question somewhat for Steven, since you're the OEM representation on the panel. You know, we've all been talking about collaborations in all the panels today. And Martin had kind of highlighted, well, today there's a lot of people providing a lot of different points, and we may consolidate that a little bit more. What can the industry do in order to in a collaborative manner to help with these architectures, right? Because we're so focused right now, I think today, on a singular type of ECU. And now we're kind of like crunching them all together and making it so much more complex. There are so many people out there. If we start to, you know, consolidate all that down, even at a software level, I think it makes it harder for maybe new solutions to pop up. I could be wrong, of course. What is your take on that?
So I think collaboration is evolving, and I mean, we're collaborating today. The aspects of collaboration might not be obvious. I mean, most OEMs are dealing with, you know, a couple dozen tier ones, and the tier ones are producing these singular modules, and they're likely producing very similar modules for each of us. Of course, some of the code and feature set might change depending on the requirements. So there's that. The open source, you know, a lot of this stuff is running on open source and is being, you know, tweaked and customized for the feature set needed. And as we get to, you know, kind of this consolidated compute, we're going to see more of that, except it won't be kind of at the hardware layer as much as it potentially has been. It will be more at kind of the container and the software that's running inside those containers on the larger compute. Obviously, there's going to be more containers than there traditionally has been in the past, and I think that collaboration itself of reuse will be there as we go forward. But I don't know if it's going to be completely obvious to anyone once you see that vehicle running on the road. There is lots of collaboration today, and I can only see that it will continue to morph as the business models support it overall. So just my perspective kind of in what I see in my day-to-day.
Martin or Eric, I guess, do you have anything to add to that?
Yeah, just in terms of some of those security challenges that, you know, will come up whenever you start consolidating this. One piece of that is looking at what can be updated and what cannot, because as Martin said, you know, you do gain a lot by having sort of a common platform that everything's going to run on. But the potential challenge there, or the potential risk there, is that if there ends up being a vulnerability in that platform, it could compromise potentially many cars across many OEMs, right? If someone is selling a solution that's supposed to isolate all these different processes, and they sell it to GM, Ford, Toyota, whoever, and they use it in many model years of vehicles. The damage potential of a vulnerability in that could be absolutely massive, especially if it's dealing with some of the networking components that might be directly exposed. So it does bring in an interesting part of that about asking about updates and saying, do we have to be able to update these types of systems? How much longevity do we really think we can get out of a virtual machine software or a hypervisor? One great example, I think it was VMware. Don't want to be wrong on that, but one of the popular offerings had a bug a few years back, and it was a floppy disk driver that obviously no one had thought about in many years, but it was like a critical severity bug where this floppy disk driver would give you access to the host memory directly. So things like that do come up. I don't think anyone should think that we're going to somehow test them all away. So it's a matter of how you respond to those types of threats against the actual system software.
Yeah, and the threats need to be looked at in the context of, what does it do to the operation? What does it do to the comfort of the customer, the user in that vehicle? Your floppy disk scenario, interesting, but you almost need to be more local to take advantage of a floppy disk drive issue potentially.
Well, the issue there, though, is that it was the driver that was vulnerable. So from the software side, you could actually get through.
Sure.
So just no one had looked at this software because it was old.
And I think you both touched on a couple things I want to highlight, maybe dig into. But one is kind of the concept of security decay, and I think there's a lot of people talking about this now. I think the industry's kind of caught into this. Is it's not just hardware that fails over time. Processors get faster. New people discover things. Crypto gets easier to break. Everything, right? So I think that's something. The more logical and the more software there is, the more decay there is. Because I actually think from a cybersecurity point of view, software actually decays faster than hardware, right? And then the other thing you mentioned open source, Stephen, and I think that's also a point is yes, consolidating and having more similar solutions. Well, that increases the value to an earlier question. It also increases the impact of a compromise. But I think the more open source that's used in that, the higher that risk because there's more people looking at it. And I'm in no way against open source, right? But I think when we're talking about modeling the risk, this is something we really need to consider. How are we making sure we stay ahead of that life cycle as well? Well,
OTA or over-the-air updates is key to helping with that software decay, as you coined it, Martin. And it's I expect that we will continue to have to update software that's in vehicles on the road, that are out there today. They need to be updated longer term, and as the decay, if it does start to increase, we have to OTA more. So those gains that we get in consolidation early may come at a greater cost later with OTA. Another point that I'll call out from an OEM perspective is, hardware fails at one rate, software will fail at a different rate. Having a larger compute platform actually might allow us to have it longer and to test those interoperability versus having fleets of vehicles that are 3, 4, 5, 6, 7, 8 years old to go back and patch and test before we release to the customer. So in one way, I think our physical assets may actually start to drop in numbers, even and allow us to upgrade, patch, feature enhance, and push those out over the air to help the customer be a little more convenient and not actually have to go back to a dealership or download something onto a physical memory stick and jam it into the dashboard to do that update.
So somewhat in the same vein, we cited that software and hardware are going to degrade at a different time from security perspective. how, I mean, we've seen that it reduces the cost for the OE. Well, typically it's cited as reducing costs because you're producing less modules for the vehicle. But do you think that the software and integration cost is offsetting that in any way? The question can go to Stephen first.
I think it's too early to tell. You know, there's theories and then there's measurements, and I don't know if we've had enough time to measure to actually show one way is better than the other. So I won't claim that the costs go down with consolidation, because I'm not sure they actually do. But I think the feature set, the price per feature goes down, the more features increases when you've got, you know, quote unquote unlimited hardware to run these features off of. So I think that's where the real intent or gain is in this play. I don't necessarily think it's going to drive down, you know, the lower cost of engineering and design up front. You know, and it might actually balance out. You might go from, you know, 10 ECUs, traditional ECUs, to, you know, 2 or 3 as we do this consolidation. I'm not sure we're going to go to 10 to 1, but I think we will go to a lower number. It just may not be as drastic.
Anything, Eric or Martin, on that?
I think the integration costs, I have no idea if they'll go up or down, but it'll be interesting because there's just a lot of factors at play there, right? You have from 10 ECUs to 2 ECUs now, just the harness requirements and, you know, manufacturing, like that pulls everything in. I don't think anyone can make an easy guess right now. But it's interesting, Stephen, saying like the cost per feature, because yeah, if you can get all this compute power and you don't need to keep bolting on modules, what does that get you, and what upgrade paths might that get you, like additional longevity for those hardware platforms? So it's an interesting question, but I don't think anyone's going to come up with the answer right here.
Well, since you're currently addressing, so how do you think from a testing standpoint, like, do you think it increases the test load like exponentially just due to the complexity, or do you think it remains roughly the same as 4 or 5 modules being consolidated into one?
It's a bit of both. So it depends how you look at it. For integration testing and functional testing, it might actually be a lot easier, just because you can do a lot more with simulation without needing specialized hardware and things like that if it's all running in the same environment. The security side of it will be, yeah, we'll see. It does increase software complexity, and in general, with increasing software complexity, increases the security requirements and the testing requirements. One thing that we end up looking at when we look at cars is trying to do the threat analysis in order to determine what controllers do we not really care about as much. Usually there's a few that stick out as really important. And then there's some that, you know, we want to look at if there's anything egregious, or if there's any ability to get a sort of a foothold into the vehicle network or persistence on the vehicle network. But what this could change is, well, you know, we had these 10 ECUs and none of them were particularly interesting to an attacker, or maybe only one of them was interesting to an attacker. But now we have these 2 consolidated ECUs. They're both very interesting to an attacker, and now they both have additional security requirements. So it'll depend how it splits out and where this actually gets used, but it could sort of go either way.
In that last scenario, Eric, I could see as maybe a single security control could be used for both of those features as well that are co-located, instead of, you know, having that same feature in 2 different areas of the vehicle. Of course, from an attacker, you gotta overcome that control, whether it's singular on a co-located device or distributed on 2 devices. So, yeah.
But you could also, with that extra compute power, have better controls. That's
absolutely
that's another nice thing.
Yeah.
So, yeah, for example, let's take this to its logical extreme, which is that there's just one controller in the car that does everything. I don't think we'll get there, but you know, things like diagnostics, which right now you have a bunch of different algorithms running on different controllers, often depending on the supplier, how it's implemented. They range from okay to not very good. But if you had one controller that had all these resources, you could implement some very robust diagnostic authentication algorithm that just unlocks the right things perfectly. And it would be more complex, but you'd also have the resources there to do it.
Yeah, the authentication
I
and the authorization of what levels
Yeah.
are exposed. Yep.
Yeah, I agree, and I think if you'd say you take 3 modules and you and they all need the same security control, you not only save the space of implementing it 3 times, but then maybe you have actually the budget to entangle the controls together, right? So one of the things that that we still as an industry I think struggle with is we have layers in the onion of controls and security mitigations, but they aren't really tied really well together, right? Once you get through one, you have to go through another one, but it's not like you have to solve both of them at the same time, if you think of it like a puzzle, right? And I think more budget would let us do more interesting things, not just more robust. I want to come back to the system engineering question too, because I think one of the reasons why the cost per feature goes down is because you don't need the compute power all the time for all the features, and so right, it's just like the cloud and everything else. It's all about resource sharing, and to me that means the complexity, the test complexity, is exponentially higher because how many different combinations of things running at the same time have to be run, right? And okay, depending on how many things you're consolidating, to Stephen's point, maybe the complexity isn't that large, but if you consolidated 10 or 15 different modules with multiple features on them, then that's actually a lot of different options. So I think from the tooling and the infrastructure, and this is maybe a place for industry collaboration, right? You talk about model-driven engineering, you talk about automated testing, you talk about automated security testing. These capabilities, I think, need to improve in order for the cost to be lower, right? So I mean, I'm not going to predict whether it's lower or not, but I think if we put the right tooling in place, we actually may be able to make the cost lower. And then I think I would posit a crazy idea is, well, maybe we also need to think about it like resiliency and robustness and safety critical systems or whatever, and start thinking about, okay, well, how can we respond to failure? And not only just try and prevent failures, but also how do we recover, and are there ways which we can reduce costs by covering enough things so we make sure that that passengers are safe. I'm not suggesting we make too many compromises, but there are things which, okay, well, that thing reboots and it takes 1 second, and and the passenger is not really annoyed, but we just saved ourselves a massive amount of cost. So I think that balance will also need to be walked, I suspect.
So I have a question on that. Then you said that some portion of the system would restart versus a module being non-functional, right? In that same vein, do you think it'll be easier to do, say, like long-term warranty and repair claims on these types of things? Like, will the complexity maybe allow for more flexible updating methods that prevent that, or will it be more expensive if something does happen?
So go ahead.
Sorry.
Go ahead, Stephen.
As an OEM, I don't know what's I can't predict, Joby. Sorry, I'll throw it back to Martin.
No, I know it's not directly cyber related.
Yeah.
Thanks.
Yeah, and I think that's tough, but I would posit that, I mean, just logically, right? Hardware failures are going to be more expensive by definition, right? Because the module is now much more expensive. How that works out in the reliability engineering and how warranties work, I mean, I'll leave that to Stephen. I'm not even going to touch that one. But from an updatability, I would expect that it's easier to do incremental updates, and it kind of comes to the security controls discussion that we were having before. Now there's a certain amount of resource we can put into updates and incremental updates and verification of updates. I think by sharing that infrastructure, or at least parts of that infrastructure on a consolidated module, that we'll be able to do more, right? Whether everything is going to be updatable in infinitely small amounts, so you can send a 3-byte update and it doesn't stop the function running. I doubt we're going to make that kind of investment as an industry, but we can do more.
So, Stephen, you had mentioned overall feature set in a couple times, right? So, this complexity obviously is going to have its benefits, and one of them you said is increased feature set. Now, as we get more features into the vehicle, each one of those likely has its own sort of interface, whether it's an edge or cloud or customer device. How does that increase even the threats that are available? Because, you know, I mean, they may communicate over different or the same interfaces, but each one, is it considered a separate entity of threat, I assume? Yes.
Yeah, there's different reach there, right? And we've got to look at the interfaces as to, you know, in a way, I think of, are you going to bring a device into your vehicle that you want to hurt your vehicle? I don't think most people are like that. Maybe Eric, but I know he's going to do that in a safe environment. It'll be up on blocks in a garage or something if he's going to attack a vehicle that he's sitting in. Things that, you know, in the past have been most interesting is the stuff from remote. You know, and that's cellular, that's Wi-Fi, that's Bluetooth, and each of those have a different range as well. Cellular, we're not putting the controls necessarily in the ECU, we're putting them in the telecom layer, in the quote unquote internet layer, so long as we're not violating privacy and regulatory impacts. We want to monitor and to make sure that everything is going clearly across and you know, happening from, you know, the cloud to the car, the edge to the car. And then, you know, Martin and everybody else kind of has already keyed on this too. If it's going to be that interface between the customer in the vehicle and the module, the high compute module itself, we'll be able to put some more kind of intrusion detection or some more monitoring or some more inspection there, so that you know, we can make sure that our hardening controls and the controls that we want stay intact. So, you know, Joby, there's going to be more features. We all, as customers, want more features. You know, we want the car to take us somewhere and not have to stay awake and drive. You know, that's one of the biggest features. But after we get, you know, after we realize we're sitting there and it's taking us to where we want to go, we're going to want more entertainment, we're going to want more productivity. We're going to want to do kind of these conferences as we're traveling down the road instead of, you know, sitting in a room at home thanks to COVID. But you know, I think we're definitely on the path to more features. Everybody wants more features, and the security controls have to keep up, and they don't all have to reside on that single module. It can, the controls can also be distributed in the right choke points.
Eric is an attacker. What do you think about that statement? Not trying to pitch you against each other, just
I'm always a little leery about the like, I agree, yeah, most people aren't going to bring a device into their car that they know is malicious. The challenge is always, do they know it's malicious? Automotive has had less of a bad story here, I guess. One thing in trucking that's interesting is the ELDs, the like mandated data loggers, because some of those have not good security, just really bad security. And what you end up with is, you know, someone, they buy this device, or their fleet manager or whatever gives them a device, they stick it in the car because they were told to, and they have no idea. And now the OEM that made that vehicle, they go, like, it's not ours. That comes down to a question of, you know, who should we be trusting with that, and, you know, where that responsibility resides, which is a whole other topic. But with this isolation, it actually, so one place that you see something like this, I mean, it's done with hardware, is in head units right now, right? So most head units right now will have an applications processor that runs Unix or Android or whatever rich operating system that's got your display, Wi-Fi, Bluetooth, all that stuff. It will then talk to a secondary processor that talks to the vehicle through CAN, automotive Ethernet, LIN, whatever it is. And that interface is, you know, well-defined, and then depends on the implementation. In really good implementations, that secondary processor is very restricted in what it can do and can't do. So it almost is acting as a, you know, isolation between the two. This sort of lets us do segmentation like that, but on a much, I guess, cheaper and more constrained version, where, you know, you could do things like, let's say my car talks to an update server that the OEM has. My car also is connecting to my Dropbox account to pull some files off it. I don't know. Right now on most head units, those two things are existing in the same system. depending on if it's Unix or Android, they might be using some amount of separation. But it's pretty close to each other. We potentially see an option there where you could separate things like that out. Like, why should my OEM be able to see my phone book or my contacts list? They probably shouldn't. And that's another place where it might be very useful, is we could actually do better security, just because the cost of separating those things could go to zero.
So Martin, any takes on that?
Yeah, no, I agree with that, and I was going to actually pose the question to my to the other panelists here, and you maybe, Joby, but in some parts of the world, mainly China, they're already deploying third-party developed JavaScript applications to the head unit through WeChat, right? And I think this is happening, and maybe there's an opportunity to do more, right? By having the same level of separation or similar level of separation and controls as you would have, say, for the component that's actually talking CAN to the device, for, say, third-party things or things which you trust less. Maybe that actually helps us. But I'm actually wanted to put that question of, now if we talk about mobile phones and JavaScript apps and third-party ecosystems, I think this will exist. I believe to different amounts in different regions, but it's coming, I think, to some degree. So I'm curious what Eric and Stephen think about that.
Yeah, I guess it's already started here. We're running Android on a lot of head units, right? Like, lots of new head units out there on Android. I don't think that's specific to any OEM. You can look at, I think basically any OEM probably has a car running Android now, maybe with a few exceptions. And that, you can run apps on them. Now, they might not provide the interface to install them and everything, but if you want to run your own apps on it, you often can. And people have been doing that for a while. The question there becomes, do you really want that? Basically, it's a tablet in your car, right? That's functionally what this thing is. Do you really want that talking to anything that has to do with managing the vehicle at all? And I would argue if we can prevent those things from being able to interact, we should. There are things like, we see SD Linux and different software controls that are containerization, things like that. But can we go one step further with that? And this approach might be able to do that while also pulling in some features that we wouldn't normally associate with the infotainment. But one of those that I see, most likely thing that needs a lot of compute resources are things like autonomous driving and ADAS, things like that. But of course, they have a huge safety problem, or safety concern rather. So it's an interesting question of what the isolation for those new threats that come in. That's one thing. But then the other side of it is, what can we pull into that system now that we have the better controls? Kind of works from both ends.
Yeah, and we're not, while many OEMs have Android running in their vehicles today, it's not the wide open Android from your like the Android you're running on your mobile device. It's not got the full Play Store in it. It doesn't have unlimited amount of apps. So we're still in the childhood stages there, and it's about the way we've been dealing with it is deep inspection of the app before it's released to the vehicle, and what it can do, and making sure that the necessary controls are in place. But like I said, as customers want more and more features and demand more and more features, it will get more challenging, and we're going to have to look at it and make sure that the appropriate controls are still there as we get to more of a heterogeneous and app framework that everybody wants.
So in this vein, I do have some experience having worked in the China market, and it's a completely different thing, right? What they want on the head unit as far as feature sets is vastly different than that of Europe or India or America, right? Even South America, right? So do you see something where apps can just run in their own sort of maybe virtual address space on this super module, where it doesn't matter what they do? right? Like, so we can just allow the customers to put what they want on the vehicle, right? Because I mean, I remember hearing that people were putting YouTube on their smart mirrors so they could watch videos when they're driving down the road in China. Um, is that something that you think that we could allow from a security perspective? Do we have the controls maybe to do that?
There's more to come, Joby, but I think the perspective of the folks that were able to circumvent the existing controls and put YouTube there did that on their own, for their own benefit and on their own behalf, which, you know, kind of in the legal construct, I believe that keeps OEMs, much like mine, you know, we didn't intend for it to be there. We put controls there, but someone, you know, someone ingenious was able to circumvent some of those things, and they took that extra step. As we think about video playing on the head unit, it doesn't seem like a good thing from a NHTSA, National Highway Traffic Safety Administration perspective. We wouldn't want to do it because it would violate those principles. But again, you know, as long as the customer keeps their eyes on the road and their hands on the wheel and their feet on the brake and the pedal, they can be safe, even though, you know, in the corner of their eye they're seeing video playing. Yeah, it's not something we intend to do or we want to happen, but I think it has happened in the past, and it may in the future. And part of it's because of software decay, or control lapse in controls.
I just wanted to be real quick, Martin. I apologize. I just wanted to be clear. I was not calling out any specific OEM whenever we were talking about that attack. It's just in general the market and
right.
What we've seen. Okay.
Yep. Yep. And I wasn't
ahead,
speaking
Martin.
on just
Sorry.
my OEM. I was speaking on the collaboration and everyone.
Thanks.
Yeah, I just wanted to add that I think, you know, it begs when you start talking about, okay, well, you know, users want to put YouTube on their smart mirrors. You know, it reminds me of some of my previous industries where, you know, a lot of the problems you have with controls being overcome has to do with doing things that users don't like. And, you know, there are sometimes really good reasons, business reasons, regulatory reasons, etc. But, you know, one of the things I think as an industry we don't think about enough is what am I doing to make my user experience good, such that, and support the things my users really want to do in a secure way so that they don't go around my controls, right? And that actually decreases, and in some cases, you know, I've seen in industries where it decreases the number of people who are interested in compromising the controls by like 100,000 people, and then, well, the controls don't get compromised as much, right? Just from the sheer kind of question of numbers. So I do think we also need to think about, are the controls we're putting in, you know, only thinking about our perspective and how we're building the system, or are we really thinking about what our users are going to end up seeing those controls like?
Eric, anything to add before I move on?
I'll just say, if you want a great example of what Martin's talking about, look up the history of the PlayStation 3 getting hacked. Would not have happened if they hadn't have disabled installing Linux on it.
Yep.
Yeah, I can mirror that sentiment, is that I've seen the more you lock down things, especially if you think about vehicle enthusiasts, right? I think all of the OEMs that we know, and everybody here has the favorite vehicle, right? And there are enthusiast forums all over the place, and those guys are the ones that are really trying to get out there, because, you know, they want to make their cool thing even cooler by doing some feature or have some image or something that they want, right? And so people think a lot about vehicle hackers. I don't honestly think that they always think about those people who just want to make their car cooler and help others do that as well. So I think it's a really, really great point, Martin. We have about 5 minutes left in the panel. I just want to ask kind of a fun question, like, what is this consolidation like? What does it enable, or what's the coolest thing that you think from a technology standpoint that it provides, either as like a developer or as a customer? Just your personal opinion. And since we left off with Eric, I'll start with you again.
Well, I think one of the neatest things that this could provide is what we were sort of hinting at there, which is can you get a level of isolation where you can run untrusted or less trusted things on a vehicle to the point where you could actually have a developer community for your car, right? So, the reason that we all got phones in our pockets and, there's two types of phones that we have in our pockets has a lot less to do with the fact that they're phones and a lot more to do with the fact that they're this general purpose computing platform that anyone can make an app for. And if cars could get there's probably some really neat things that could come out, especially when we talk about autonomous driving where you don't actually look at the road anymore. But even before that, I'm sure there's tons of great things that could happen there. And if this is what enables us to get to that point where we can say, okay, well, the controls are in place, we're going to let people run in such a way that they have access to a few, audio and the screen, things like that, but they can't do anything to the vehicle itself. That might be what sort of pushed us over the edge and allows us to have, hey, the Play Store is on my car now. I can just install whatever the heck I want, but it's not a huge security risk.
That's really cool. I think the concept of a widely available vehicle SDK would be pretty interesting, right? Because we've seen what people have do with like other types of SDKs. I mean, not to get too off topic, but we've seen what people can do with like mods for video games, right? It's incredibly interesting, and could that customization be brought to the vehicle as an SDK form would be interesting.
And can we lock it down? That's
sorry.
So the safety issues don't come up.
Yeah, exactly.
Assuming we can do it.
Fun. Yeah. Martin, what are you most excited about?
Yeah, so a variant of the same thing, actually. I think that Eric's answer is a great answer, but I think I leapt ahead, and I think once you start to talk about a consolidated module, you talk about more CPU, you talk about more GPU, you talk about maybe Tegras and things, right? Like, so you're talking about not just incremental capability, but maybe even, a non-linear kind of growth in capability. And if the cost of replacement, when we were touching on warranties, cost of replacement is such that gets replaced more often, right? Like, so there are TVs, you can upgrade the smart part, right? Will there be cars where you can upgrade the smart part? There are some now, right? Already. That kind of then there's like this exponential growth in the stuff that's available. So yes, we need first the security, then we need an SDK, but then think about all of this, GPU and CPU capability underneath. What can't we imagine that people are going to be able to come up with for that, right? And maybe it's even beyond modules and like mods for games. Maybe there's even secure ways, and I know now I have no idea how. I honest, but think about, could there be secure ways to interact with ADAS, right? And that a developer community can actually add. I mean, I'm not that they're going to solve the ADAS problem, but maybe there's some useful additive things, AR things, whatever, right? Like we don't know, and I think unleashing the world's creativity and how to add to the experience in the car, I think to me is kind of the same thing. But I look at it more as, what could I do as an app developer in a car with a bunch of GPUs?
Sure. And Stephen, we got about 2 minutes left here. What are you most excited about?
Yeah, I'm excited about a lot of things, but every time I start to like wander off into these areas, I always think of, man, the OEM and the customer at large is gonna probably, maximize the available compute that's there, even when we go to a larger scale compute. And I'm hesitant to say there probably won't be anything left over and available for, guys that are very creative and given an SDK is, so in a way, I'm going to ground us on that one, but the sky is the limit, and it would be very neat and interesting to see that these that vehicles turn into things like the traditional tablet and phone, where there has been a development community that's been spread far and wide to bring stuff in. So,
all right, well, thank you for wrapping it up there with us. I'm going to go ahead and say thank you all again. I really appreciate you showing up for the panel. I think we had a lot of great discussions, and not all of it was cyber focused for those of you out there. I think we tried to keep it a mixed bag of topics.